All right, so on this question, it's question 19 from practice test 1. Question identifier is 3.1.20 or 20. So from section 3.1, 4 siblings are 1, 4, 5, and 9 years of age. Complete parts A through E below. So we're first asked to calculate the mean. So we will use our calculator, we'll go to our stat menu, and we are going to edit. So I have some data from the previous question. I'm going to come up to the where it says L1. I'm going to hit clear. You can either arrow down, hit enter, whatever you feel like, and putting your data in. 1, enter, 4, enter, 5, enter, and 9, enter. Once I have that data, I'm going to do stat, go over to my calculate menu because I'm calculating my one variable stats. My list is correct, go down to calculate, hit enter, and I need the mean. The mean is 4.75. Come here, buddy, my poor dog, he misses me. So I'm going to go ahead and put the text box right here. It's okay. And it says round to the nearest 10th. So our 10th place has a 7. So looking 1 to the right, 5 tells me to round up. So my answer, okay, is going to be, took it away. It's going to be 4.8 years old. So that would be the mean age of those children, okay? Without doing any calculation, if we were to add 10 to the year, so they're saying if the mean age in 10 years, what do you think it's going to be? So if they all increase by 10, will it be larger, smaller, or about the same? So if all those go up, your mean, oh goodness, buddy, is also going to go up. So the mean's going to be larger, right? So let me highlight that for you. Because the mean, we're adding all those together, the mean's also going to go up. Now we're going to check our answer. So this is a cool trick. Let me show you. If we go to our list, so the second stat, we're going to edit our list. You don't need to manually add these. I mean, you can, it's really not hard. But what I like to do, because if you practice on things like this, if you get to a hard one, you'll be able to. So if you go up to where it says L2, right? And you hit enter, it's going to bring you down here to like this little, where the flashing cursor is. I can enter L1 in there, just using that like second and L1 key. And then I can say the L2 is equal to L1 plus 10. So it's going to take every entry in my L1 and just add 10 to it. So it does it for you, which I love that. Because I mean, this isn't hard, but if you have to do something different on a different one. So it's just a nice little trick, helps you out. So once we have that, the only thing you need to remember though, is to do our one variable stats, we need to make sure that we're putting L2 in for our calculation. So when we do our one var stats, change this to L2 because that's where our data is now. Come down and hit calculate. And so our new mean is 14.75. So I'm going to bring this over here. 14.1/10 would be 14.8. So adding 10 years to all of them raised my mean overall by 10. So that's good. Next, calculate the standard deviation of their current ages. So this worked out well. I didn't get rid of my original L1, so I don't have to re-enter it. What I can do is just go to stat. I'm going to go to my calc and I'm going to hit one var stats. And then again, I'm going back to L1 data. I'm going to go down. I'm going to hit calculate. And so it was 3.3. So I'm going to put that in here as well, 3.3. And without doing any calculation, indicate whether, okay, so if you think about it, what's going to happen to the standard deviation? So what is the standard deviation measuring? So the standard deviation is measuring the distance between them all. So if we're talking about the distance between them, do you think that in 10 years it's going to be larger, smaller, or the same? So I'm looking how far apart they all are. But I added 10 to all of them, right? So 11, 4, 15, and 9. So we think about that. Are those about the same distance from the mean, or do you think they're going to be further away from the mean? What do you think? Well, what was our mean? Our mean increased as well, right? So if the mean increased by 10 and each of those numbers increased by 10, they really should be no difference. So our standard deviation should stay the same because we haven't changed the distance between them. We moved them all, oops, I meant to highlight that. We moved them all up by the same amount. So the standard deviation should stay, oh goodness, should be the same. Okay, let's check our answer. So again, let's go to second, oh, not second, I keep trying to hit second. Let's go to stat, I'm sorry. We're going to go over to calc, again, one variable statistics. We're going to second L2, because that's where the second data set was. I'm going to come down, I'm going to hit enter. And let's see, our S is 3.3. So yes, that worked. Our logic was correct. That's a wonderful feeling. Sometimes it's not, just kidding. So 3.3, so it did stay the same. And let's talk about what happens. And I'm not sure if all the words are going to be on here because it did cut off, but we get the idea. So adding 10 years to, oh, I don't need to highlight all this, to each of the siblings' ages had different effects on the mean and standard deviation. Why did one of them change while the other remained unchanged? How does adding the same value to each number in a data set affect the mean? So if you add the same number to the mean, it's also going to increase the mean, right? Because it increases the average value of the ages. By adding 10, the average value of the ages increases. But what we said earlier, the difference in the ages remains consistent. Because when we're thinking about this, what we looked at, if you make the mean increase and the ages all increase, then the difference between them does not change, right? And so your mean increases, but your standard deviation will remain the same. So I think that's part A. I was trying to highlight. Okay, so that would be question 19 on our practice test. And then the identifier is 3.1.20, okay?